we're going to characterize another hyperbola, and this time it is a horizontal hyperbola, and I can tell that right away from looking at this equation because I see this. There is a negative y squared, and negative y squared or positive x squared means we're dealing with a horizontal. So that's always good to characterize right at the beginning. So let's get the positives on the left. That's my 36x squared, and ooh, yikes, minus 216x. Okay, and then on the right side of that, I have this. I have negative 9y squared minus 18y. That's not too bad. And then let's just put that 9 over on the right side of the equation here. So factor out what you can. Let's see what we've got here. This becomes a GCF of 36 on the x group, and that leaves behind x squared minus 6x inside those parentheses. And I'm going to leave a little space for something else. Then I factor out a GCF of 9 from my y group, and that leaves me y plus 2y, or y squared plus 2y. And I'm going to leave myself a little bit of space there. Okay, and that all equals 9. Great, I haven't really changed much. I just did some GCFs. Now what we want to do is complete the squares. And the first thing I'm going to do is think about this x squared minus 6x. Well, what is that? That's kind of like this. It's like x minus 3 squared, right? Except when you square that negative 3, you're going to find you get a plus 9. So we have to add that plus 9 in here, which means we also have plus 36 times 9 on the right side to keep the equation balanced. Now, if we look in the y group, we've got, what do we have here? This is a y squared plus 2y. Well, that's kind of like y plus 1 squared, right? And when we square that 1, what do we get? We get another 1. So we got a plus 1 here. And don't forget, we've got a minus 9 times 1 to balance that out. Now, don't forget the rest of everything. We've got this 36 GCF there. We've got a minus 9 over here. And now this is a balanced equation. We've completed the square. Except, well, what does all this stuff over here equal? Right? We have to do 9 minus 9 times 1 plus 36 times 9. Well, that's great. 36 times 9 equals, not something I have memorized, equals 324 when we add all those things together on the right side. Okay, great. Next step to getting this in standard form is divide everything by 324. The purpose of that is so I can just say on the right side equals 1. I need that. And then in the middle group, I have this y plus 1 squared divided by, well, 9 over 324 is equal to 1 over 36. And over here, I've got an x minus 3 squared, 36 over 324. So that's over 9. Great. This is standard form right here. So I'm going to take that guy, put this in right here. There's my standard form equation. And from that come all the key features of the hyperbola. The center, which you can see right here, it's these offsets, these shifts inside the parentheses. The center is going to be located at x equals 3, y equals negative 1. Okay, so that takes care of that. The vertices, if you think about the orientation of this, it's horizontal, right? So the vertices are going to be located left and right from the center. Now, a squared goes with x, and that's equal to 9. That means a equals 3. So we're going 3 left and right. That means the vertices are located at 0, negative 1, and 6, negative 1. The co-vertices are up and down. And the direction these go in always depends on the orientation of your hyperbola. See, this is my horizontal picture right here. I've got the center. I mentioned that earlier. The vertices are left and right. The co-vertices are going to be up and down because this is a horizontal hyperbola. That means co-vertices go up and down in this orientation. So we go up and down by what amount? Well, that's going to be b squared equals 36. That means b equals 6. So I'm going up and down by 6 from the center. So this becomes 3. Negative 1 minus 6 is going to be negative 7. And then 3 in x location, negative 1 plus 6 is going to be 5. There we go. So what's left? The foci. Well, if you think about where the foci are located, remember they're in the same direction as the major axis here. And they just go a little bit further than the co-vertices. So, I don't know, there-ish. And the way we find those is with this formula for foci. c squared equals a squared plus b squared. That means, well, for us, I think a squared was, 9 plus 36. So that means c equals the square root of 45. And if you want to simplify that, fine. You can call that, what's that going to be, 3 square root 5? That's fine. It'll be correct either way. So what we do is we take the center point and we march right or left by 3 radical 5. I'm sorry, these are a little ugly. So the first one is going to be located at the center, so x equals 3 plus 3 radical 5. The y value stays the same. And the second one is going to be located at 3 minus 3 radical 5. Again, the y value stays the same. Now, the equations of the asymptotes are not too hard if you're good at thinking about this as a graphing window. Okay, those vertices and co-vertices form this rectangle around the center. Oops, I went too far. There we go. A rectangle around the center of the hyperbola. And if you look at it that way, it's very easy to see what the slope of this dashed line is, because it's going up by 6 over by 3. So that is m equals 2. So we simply make this equation y equals mx plus b, and we plug in the center point for our y and x. So for us, the center of this thing was located at, 3, negative 1? Great. So I plug in my negative 1 y, my 2 slope, my 3x, and say plus b. So this becomes negative 1 equals 6 plus b. That means b equals negative 7. So the equation for that asymptote that I just drew is going to be 2x minus 7. No fractions, that's a treat. And next, what do we have? We have the other equation, of course. So that's one of the equations. The other one is going to look like this. I'll do this one in dark blue. So this is going to go down, right? They're not perpendicular lines. Here, I want to talk about this, but we need to finish the discussion about asymptotes first. So you go over here. I will get to this, but just give me a moment. So that asymptote that's going down, the way we do this guy is we say, okay, what's m equal to? Well, it's going down by 6 and over by 3. So that's m equals negative 6 over 3, right? Rise over run, that's negative 2. So now I say y equals mx plus b. The center point has not changed. Remember, that's negative 1 in y. The slope is negative 2. The x value is 3 plus b. Okay, this looks pretty good. So that's negative 1 equals negative 6 plus b. And for this one, that means b equals 5 when I solve that. That means the equation for this asymptote is going to be negative 2x plus 5. Okay, that's everything we need for this hyperbola to be fully characterized. I know all the key features, all the asymptotes. I just want to bring up one last thing. If you look at this shape, this is really cool. If you look at the shape, you notice it's a horizontal orientation. All right, let me get rid of all the nonsense in here. It's simply a horizontally oriented parabola. The curves go left and right. However, if you're looking carefully, you'll notice that this distance right here is huge compared to the other one. It's very tall. This viewing window, the b value is much higher than the a value. Well, that doesn't matter. It's still a horizontally oriented hyperbola because it opens left and right. The key here is not whether the minor axis or major axis is bigger. That doesn't matter. This is not an ellipse. The key is what's positive. In this case, it was x that was positive, so that means it's a horizontal hyperbola.